Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at how does the law of the ambiguous case for the law of signs work. Now, in order to do that, one of the things we have to recognize is that we are looking at a very specific situation to occur. If I have a triangle like this, and I am given A, this angle, and I have this side, and I have this side. Notice we have the angle side situation going on. That's the bad word. Now, the reason why we don't like this is because there's actually a triangle that can be formed inside of the triangle that we're looking at. And this triangle is an isosceles triangle where this angle and this angle are now congruent. And I have this situation where one triangle is big and one triangle is small. So we have two triangles that are happening here. And the two triangles that we have is this one. And then we have the inside triangle, which curves down like this. Now you'll notice this angle out here is the supplement to this smaller angle there. So in order to figure out what this angle is for our B that changes, B1 is this angle, and B2 is this angle. These are supplements of each other. So in order to find B2, we can simply take 180 degrees and subtract angle B1. And that's one of the things that we're going to do based upon this picture where we have an isosceles triangle sitting smack dab in the middle. Now that's what's happening. And the reason is because the side A is acute and our height, so we have angle A is acute. Let's try that again, please. Angle A is acute. And we can see that A is less than B. And when we have an acute angle and A is less than B, there are three possibilities that we could have. We could have a situation where we do have this and having two possibilities caused by this leg swinging across. Or we could have a situation where we have just one triangle, and this will be a right triangle. And then we have a third situation where the triangle just doesn't exist. Now, each of these is based upon the height and our side A. We know from the other day and from the law of sines that the height given angle A and side B is height equals B sine of A. And when the angle side A is greater than this height, B sine of A, there will always be two solutions. If the height is equal to B sine of A, there will only be one solution, and we're looking at a right angle. And finally, let's put in our height. If A is less than B sine of A, there will be no solution at all. Okay, but these three cases only happen when A is acute and A is less than B. All right, what are the options that we have? So let's list what we can do. If A is acute and A is less than B, we have to check for the number of solutions. In order to check for the number of solutions, we are going to compare Okay, C-A-C-O-M-P-A-R-E. Compare A to B sine of angle A. And there are only three options that we get. A is greater than B sine A. A is equal to B sine A. Or A is less than B sine A. This has two solutions. This has one solution. And this has no solution. Alrighty, well, what happens if we have A is acute and instead of A being less, let's say that A is greater than or equal to B. When this happens, we have an acute triangle and there can only be one solution. All right, well, what are our other options? Well, we could have an obtuse triangle. Let's say we have angle A is obtuse. Oops, obtuse. I'm having a wonderful time spelling right now. Hopefully you don't get too frustrated with me. Obtuse. And we have A is greater than B. This tells me that I have one solution. All obtuse triangles where the side opposite the largest angle will have one solution. All right, well, what happens if A is obtuse? And we can see that A is less than or equal to B. Well, if A is less than or equal to B, this will have no solution. Now, this is our order of logic and what we're trying to do, and it's kind of like a flow chart. I either have A is acute, and I then compare A and B, or A is obtuse. Well, what happens if A is a right triangle? Angle A is 90 degrees. Well, there can only be one solution. Only one solution. Just like the obtuse. Only one solution. Okay? So this is the idea of what we were trying to do. Now, in the worksheet that I gave you, all I was asking you to do is use this flow chart in order to figure out how many solutions we're looking at. So I start off and I say, well, I have an obtuse angle in number 1. Yeah, 94 is obtuse. And the side opposite the obtuse angle is largest when comparing B. This has one solution. Here we have an acute angle, and the side opposite that acute angle is the larger angle. There is one solution. Here we have an acute angle, and A and B are equal. There is only one solution. A is acute. The side opposite the acute angle is 19, which is smaller than B. I immediately now have to check. What is B sine of A? Please make sure you are in degree mode as you do this. And I'm now going to do B, which is 20, times the sine of 40 degrees. 12.8557. Notice that A is larger than 12.8557. This has two solutions. Let's go to number 5. Acute angle. Opposite that angle is smaller than B. So I'm now going to check 20 times the sine of 30 degrees. I get 10. It is equal to the A value. We are looking at a right triangle, and I will find one solution. Now remember, when I see and find out that it's a right angle, I'm now using SOHCAHTOA. In all of these other problems, I'm using the law of sine. But when it's a right triangle, I use sine as opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is the opposite over the adjacent. I have a 65 degree angle in number 6. I have 10 and I have a 20. So I'm going to have to check. Here we go. That's going to give me 20 times the sine of 60 degrees. 65 degrees. And I hit enter. 18.1261, truncated. You'll notice that's greater than 10. This triangle does not exist. It has no solutions. I have a 40 degree angle in number 7. Side A is 10, side B is 20. I immediately go to 20 times the sine of 40 degrees. I get 12.8557. The height is greater than A. This triangle does not exist. There are no solutions. I have an obtuse triangle here with an obtuse angle A, but the side opposite that obtuse angle is less than B. This triangle has no solution. 9, 45 degree angle. I have A is less, so I'm immediately dealing with my height. So here we go. 10 square root of 2 let's try that again. 10 square root of 2 times the sine of 45 degrees. I get 10 because A and the height are equal. This is a right triangle and has one solution. 60 degrees. Opposite side is less than the other given side. So I'm now going to check my height. 20 times the sine of 60 degrees. I get 17.3205088. Well, what is 10 root 3? Let's find out. 10 square root of 3. Hit enter. Hey, they're the same. That means that my height and A are equal, and this has one solution and is a right triangle. Notice how quickly they go. Number 1, acute angle. Opposite side is less than the other given angle. I put in 20 times the sine of 67 degrees. I get 18.41009. This has no solution because the height is larger than A. 2, I have an acute angle where the side opposite is less than the other angle. 40 times the sine, let's try that again, 40 times the sine of 71 degrees. I get 37.8207. The height is larger than A. This has no solutions. We go to 3, acute angle, side opposite the acute angle is 7, which is less than 10. 10 sine of 32. 10 sine of 32 degrees, and I get 5.2991. That is less than 7. This has two solutions. 29 is an acute angle. 15 is less than 19. So 19 times the sine of 29 degrees, I get 9.2113. That's less than 15. This has two solutions. Notice we're just going to keep going all the way down. Always remember that you're looking at setting up your triangle the same way. Put the acute angle down in the bottom left corner. Set your side opposite to the acute angle. Should be A or whatever angle they give you. And then the other angle or the other side should go here. Other side, opposite side given. Please look at this when you are trying to use triangles like 17 through 27 or 17 through 28. Once again, please try them all, and the answer key is given in the Google Classroom. Alrighty, that's what we did today, Hornets. I hope this has helped. Just a reminder, please remember to look at your flow chart. A is either acute, or A is obtuse, or A is right. If the angle A given is a right angle, there is only one solution. If angle A is obtuse, look at the side opposite the obtuse angle. It has to be the larger side. If it is not, then there is no solution. If you have A as an acute angle, compare A and B. If A is less than B, immediately check B sine A and determine whether A is greater, equal, or less. That will tell you whether you have 2, 1, or no solution, respectively. If A is acute, and you notice that A is equal to or greater than B, the other side given, then there can only be one solution. Next week, we will be solving the triangles that we are finding that have either one or two solutions from the worksheet that we were just working on. So it is absolutely imperative that you go through and you find the number of solutions, okay? So that we can figure out what are the solutions to those that have 2 or 1. Alrighty, Hornets, that's it for the day. Thank you very much. I hope this was helpful. If it was, please remember to click like, and if you have comments, please feel free to make them. Thank you very much. Be well, be safe, take care, and we will see you all next week. Cheers.